Well, hello friends. Today we are going to work on the process manager because I haven't touched that for a while. And just to remind you what that looks like, here it is. So what I would like to do today is that when I sort of open one of these things, like if I press enter on it, say, or like we would have some icon for it, then I would like to get like a little window that tells me more about that process. And specifically, I would like to show what the process is actually up to. I think that would be really neat. So that's what I'm going to do today. Now, I guess we'll try to make it a little bit easy for ourselves. We'll just start a new window instead of trying to integrate this into the existing window somehow. So we can create a new class for this. We'll call it something like process stack widget. Process stacks widget. It's pretty good. Okay, and yeah, so I think that could be pretty interesting. Or actually, the more that I think about it, it would be kind of neat if like you would activate a process here, and then it would turn like the bottom of this window into like a view onto that process. But then maybe this gunk should like be over here instead. Yes, and this would be more of a statistics pane. Okay. Well, let's move some stuff around so that we can do that. Okay, so first let's go in process manager main, and let's see how this thing is built. So it's a tab widget that has a bunch of sub widgets that you switch between, right? So here's this view. It's called widget. It's not very descriptive. We'll call it like process table container instead. Make it a bit more understandable. We can actually commit that separately. And then that thing that I want to move, that's called the memory stats widget. It's here. So currently he's like a sibling of the process table view, but we will instead put him in the what's called the graphs container. So we'll just change his parent here, graphs container. And I wonder, maybe it really is that simple. Dum, dum. Cool. And now it's here. Well, it's kind of good enough for what I wanted for this right now. So I think we'll be happy with moving it there. I'll just do that in a separate commit. So let's say process manager, move the memory stats widget to under graphs. Making space for some new thingy under process table. Yeah. Okay, now I guess now we can actually start fleshing out that widget that we wanted to make. So what the hell do we call it? Oh no, here, process stacks widget. So I guess we can actually make process info widget. We can make something like that as well. And then the info widget will be something that we put below. And I'm thinking like maybe it could have like its own tabs. Would that look out of whack? Would that look strange if we had like a thing down here that also had tabs? I feel like that could look kind of interesting. Like we would put a splitter here, and then we would have the different process info at the bottom, and then you would have tabs on the bottom instead that would allow you to see like different types of information about the process. That could be kind of cool. We don't really have support for bottom tabs, but that's something we could implement later. Like, I mean, that would just be like a setting on the tab view. Like right now, we can put them up at the top, and then I can implement bottom tab support some other time. But okay, so I think that's sort of a good idea. So let's make a tab widget and put it on the bottom. Keeper. What's the keeper? Keeper is the... Is he the main widget? Yes, he is. Okay. And he only has one child. Is that tab widget? Okay. Then let's make another one, I guess. So where do we do that? I suppose somewhere like... no, it doesn't really matter. I'll just do it down here before we make the window. This one we'll call process tab widget. Process tab widget, add widget. So we're gonna have something, we'll just call it, I guess stacks. We can just start with that one. And then stacks widget. New, and we gotta include it. Process stacks widget. I don't know if we'll do the info widget. I don't even know what that is, but I don't know if we'll do that right now. We'll start with the stacks widget. So here we wanted to do like new stacks widget. Wait, and then when you add widget to something, yeah, right. So we don't give him a parent. Okay. I guess this kind of sort of makes sense. So now we're gonna have to actually flesh out that class. So process stacks widget. It's gonna be a basic G widget, and then we'll just say process stacks widget final, because we're not going to subclass this. Public G widget. And I say C object process stacks widget. C object macro I added recently. It currently it just expands to an implementation of the class name virtual, so that you can call class name on this guy and it'll tell you process stacks widget. But in the future, I plan to add some more stuff that gets expanded when you do this. So it's a good habit to already start doing this. Don't have to do it later. Okay, then we'll say process G widget parent, and we'll need a destructor. Do we need any private parts? I'm not really sure. Well, let's just go on and try to implement this and see what we end up with. So, and it's a little bit early here. Like I can tell that my brain is lagging. But we can do this. Okay. What do we want to put in this guy? So we can have multiple stacks, but I guess right now we can just do a text box. And we don't have to be all fancy, so let's just do a text editor. libgui gtext editor. Stacks editor. Now let's say set layout, make gbox layout, orientation vertical, not vector. gbox. All right, there we go. And mstacks editor. Text editor. Text editor type multi-line. This. Okay. So I think that's cool. Now we just have to add this to the makefile. So let's start process stacks widget. Okay. And let's just verify that it sort of shows up the way we would like. And maybe we can make its launch automatically on startup. Actually, that would be kind of comfy. We'll just go and where the hell is this file again? Is it, we have to edit system server main. Oh, right. Yeah, so we'll just start up a process manager. Okay. This is very cheatery, but I'm a bit lazy with this, so I just want the process manager to start when we start the OS. This is a very easy way to do that. Just add it to the system server. Bloop. All right. So of course we don't have anything hooked up to this thing yet, and we can't type in it, so we should probably disable that, but the general idea I think is good. Okay. And this spacing here is bothering me a little bit, or the margin rather. We should margin, what kind of margin do we use? 4. Let's use 4 as the margin. So where are you? Process tab widget. Wait. Process stacks widget. Okay, I think that'll do it. We'll give him the layout margin of 4444. So 4 pixels from every corner, or from every side rather. Okay, so let's actually make something so that like when we select the process, then it will like show up down there. So maybe it should just be like whichever one is selected, that's the one that shows up down here. Do we have any like select on selection change, something like that? We have selected PID. I guess we can add a callback to this guy, so we'll do something like pity on select on PID selected on process selected, and it will just give you the PID. I think that's kind of cool. Then let's see, select. Did update selection. I'm just like orienting myself here. Myself on selection. Yeah, so that's the thing that we want to hook internally on selection. I just didn't remember what it was called. So then we'll do something like on selection. This. And I guess it'll give us the index. We don't care about that, so we can just ignore it. we'll say if on process selected, selected PID. Okay, let me just close the window here. Okay. Right, I think that's good. And then in the process manager main, we can add some code here where we say like process table view on process selected PID, and maybe we'll just say like stacks widget set PID. Okay, and then let's see, stacks widget void set PID t, and set PID t PID set text. Oh wait, hold on, that didn't make any sense. There we go. Set read only true. Alright. So now hopefully we'll get notified when the PID changes, and we'll tell the stacks widget, hey, show this PID instead. Yeah, so that's working. We got 12 here, we got 12 here. Pretty cool. All right. So then maybe this guy should have some internal idea of what the PID is. Of course, this thing should work differently once we add more subviews, but like we're just gonna do one now, and then we'll not worry so much about generalizing everything. So say mpid. -1 is a good default PID. Let's say if mpid is PID, return. Maybe we'll give this guy a timer, actually. We can do it this way. Timer, and here we'll say end timer is new C timer. Bib core, come on C timer, where are you? Okay, so how do you construct this again? With an interval, so say 1 second, and a timeout handler. So this, wait, what's the prototype for this again? Oh, just void. Okay. Refresh, and finally we can just say no parent. Right, okay, then we will add a refresh function. Put this here actually, or yeah, well, whatever, we'll put it there. Okay, we'll say refresh. So when the PID changes, then we refresh. We should actually save the PID. Refresh. Okay, and now we are gonna want some C file thingy. I'll say file proc. And the PID and the stack. Right. PID. Okay. Let's say like set text. Unable to open. something like that. And return. Okay, and if we are able to open it, then let's read whatever's in it. And we'll say mstacks editor set text file read all. Can we just do that? That'd be really convenient. Yeah, it's very cool, isn't it? And I would like to have a splitter here so we can actually change the sizes, but it's really neat. I wonder if we can, I don't know, like we can get something to happen. Cat def random maybe. It's going to make the system very busy, but you can at least look here in cat. Oh, something died. Why did you die? Some assertion failure. An IPC. Well, that's not really what I was hoping to find, but that's good to know that there are ways to provoke those. But this is very cool, right? Like you can see the different stacks, and that is very, very cool. Maybe we can do something like cat dev random to dev null. And then look what he looks like. I was sort of hoping that we would catch him doing different stuff. Yeah, you can see him doing different stuff occasionally, right? Yeah, so this stack is updating automatically, even though he's doing almost the same stuff all the time. Oop. This is pretty neat. Man, I like this. Okay, that's very cool. Let's add a splitter here so that we can resize this view. So that would be in the process manager main. We want to put these two tabs into a splitter. So currently the keeper is a regular GWidget. Maybe we can just put a splitter there instead. And maybe nobody will know the difference. See if we can get away with this. I don't know if I've ever used a splitter as a main widget in a window before, but like I don't think that there should be anything particularly wrong with that. But splitter is not one of the classes that I've been working on that much. Oh, can we grab it? Doesn't really let me grab it. Why don't you let me grab that? Okay, I'm not sure. Is it that it's just too small? Something ain't right with it. Okay, well anyway, let's not worry too much about that. Let's instead just put a splitter inside the main widget. So let's say splitter and splitter, and then we'll say now G splitter and keeper, and and we gotta do orientation vertical. But maybe that's the whole thing that we need. I'm not sure. No, you still don't work? Why don't you work, bro? So are we using these anywhere? Oh, we never used this vertical splitter before. Eesh. Okay, well, probably we've forgotten about something then. So how does the splitter work again? Let me refresh my memory. So currently you can only split between two subwidgets. They're called the resizees, I guess. Or wait, no, is that even true what I'm saying? Maybe you can split by any number. Oh yeah, but you can only resize between two widgets. Sorry, I'm confused about this because it's been a while. So this is the mouse down. And let's see. When we enter it, set spacing 4. That's fine. So it is splitting the things vertically. That stuff was working. But I felt like there wasn't really putting any spacing between them. Was it really? So I'm gonna make like a huge spacing here and we'll see how that looks. Because maybe the problem was just that I was not able to grab at it. I'm not sure. Okay, so now we have a big spacer. But if I mouse down, it doesn't actually... Nothing actually happens. Okay. So we mouse down, and then the fudge is the spacing for each child. And then we try to figure out who we're resizing between. Well, I guess we're gonna have to figure this out. So let's see, we can start here and say like resizing splitter between and second resizee. See if we even get this, because I'm a bit suspicious now. Because it feels like maybe we do the mouse down, but then when we get to mouse mode, then we discover that something ain't right, and then we just abort the resize. And then we have a semicolon here for no reason. Oh, we should make it so that we can see here. Resizing splitter between null and null. Oh, wait, hold on. Okay. But if I drag, then it just stops. Well, that ain't right. Oh, we should do this actually. And let's do this also, because then we can see what they are. Because if we pass a dereferenced gwidget or a C object of any kind to debug, then it should print out the name of it. Thanks to that class name magic that I was mentioning earlier with C object. Okay, so now, yeah, we got two tab widgets, and we're going to resize the splitter between them. So far, so good. God damn, this code is a mouthful. Okay, wait, hold on. Let me verify that the splitter works in the horizontal way, because maybe something is just totally screwed up about it. So here we have a splitter, and horizontal splitting works, right? It's obscenely huge, but we'll fix that. All right. So the resize origin gives us the delta, and then what exactly are we learning here? Okay, I guess we can say mouse move debug. Mouse move event delta. See if we're getting these. Do a little printf debugging here. Oh, so we are getting the mouse events. They're just not, just nothing happens with them. Okay. Why is that? Set preferred size. I guess we can dunk out the preferred sizes that we compute. So first, preferred size. I'll save this one. See what we compute. Alright, so the first preferred size is definitely shrinking here. Now it's growing, and it's capped. And all these things look perfectly right, so how come nothing is changing? That's kind of weird. So it's almost like we're not respecting the preferred size. Gtab here, tab widget. Size. So this is so confusing, but like, do we somehow tweak the widget that we're putting? Oh, okay. So in the file manager, we're adding this tree view to the splitter, and then we say that the size policy is horizontally fixed. I think that's what allows the splitter to actually manage the size, because if we don't set the size policy to fixed, then the layout system is not going to care what the preferred size is. It will just expand anyway. So I think we need to, for gsplitter, like whenever you add a child, we need to take either the horizontal or the vertical size policy and set it to fixed for every child. So luckily we have a event for that called child event. We'll get told when we have a new child here. So child event. See event child added. if event child and event child is widget. I mean, I guess, yeah, like that. And we'll just return base class child event. Don't you sometimes wish that you could just say like base, or like, I don't know, some magical thing like base. I don't know. I hate that I have to actually write it out, because it makes inserting new base classes between classes very frustrating, because it means that you have to go and like make sure that wherever you're calling the base class, you have to update that. Anyways, so if the event child is a widget, then we'll say event child set, or do we have to ask widget? No, to gwidget child. I can even write this out this way actually. It's gwidget child set size policy. Right, so this is going to be, let's see, size policy. How is this going to work? Old size policy is the size policy. Can you even extract the size policy? Okay, we're gonna need. So I'm threatening because there's currently no way to set like an individual size policy for one of the orientations. So we'll just add a way to do that. So we'll say let's set size policy for orientation. We'll do that. And then gwidget set size policy orientation size policy rotation horizontal. No, don't curly brace me. M horizontal model policy. Okay, so then this guy we'll just call this guy. I think that's okay. Because now we are able to do size policy fixed. So size policies are like the bread and butter of the layout system. There's two size policies. There's fixed and fill, and then you have a size policy per orientation. So like there's a vertical size policy and a horizontal one. And if your size policy is fixed, that means that whatever your preferred size is, that's that size that you're gonna have. So like if your vertical size policy is fixed, then your height is gonna be your preferred height. And likewise with your width and the horizontal size policy. But then there's also the fill size policy, which is different from fixed. With fill, the layout system will just expand you in that orientation to take up as much of the available space as possible. And if there are multiple widgets sharing sort of one layout area, then they will expand equally to take up, each take up the same amount of space in the slot that they share. Anyway, so now here we are going to, for everything that's added to a splitter, we will set the size policy for the splitter's orientation to fixed so that the splitter is able to actually override the size, which is hopefully what will make this whole thing work. And then, of course, here we have to null check the child because even though we're getting an event for about a child, that child may be gone if you did some crazy thing. So we have to make sure that the child is still there. before we use it, and then we have to check if it's a widget because the child event, you can receive the child event for any C object. So GWidget is just one type of C object, but there are other types of C object too, like timers and files and whatever. And we can't cast those to a widget before we've checked that it is indeed a widget. Okay. No, you still don't care? I thought it was so good. Well, let's make sure that this is happening in the first place. Child added to splitter. We're just gonna cheat right now. And then we'll also I guess we can say here like because I thought that this would work right away, but maybe my analysis of the problem was not entirely correct. We'll see. We're crashing? We're crashing. Did I make a mistake here by doing this? Perhaps I did. Okay. Event that child, I guess. You're still dying. Okay, well, this is really weird. So it's almost like I'm calling a pure virtual, and I guess it's because I'm calling the pure virtual because this extracts the class name when we do this. Right, yeah, here. So the class name is pure virtual. So I guess it means that we're getting the child event for a child that's not fully constructed yet. Which I guess also means that we don't know that it's a widget yet. So when the hell do we make the child added event? Wow, this is going down a rabbit hole here. Parent add child. Child added. Well, we're creating it in CObject addChild, and addChild is called from the CObject constructor, so that's why it's not constructed yet, because like we're making a new widget and putting it into the splitter, and then that new widget, he's like in the process of construction, so this is like his base class constructor, which is being called before the GWidget constructor. And widget is widget virtual. Wait, why is there a virtual is widget here? That's so weird. Well, we shouldn't have that. But that's not going to help us anyway. Okay, so I think we can't rely on... We can't rely on this child being fully constructed yet. So that's okay. We'll just have to do it later then. Then we can just do it down here. Yeah, actually, why don't we just do it when we change the sizes? It doesn't really matter. So we'll just do it here. First, resize Z. Okay. And forget about this, and forget about that. And actually, let's go here at Z object and say, make a little note here. Note, child event. You may get child events for objects for children that are not yet fully constructed. Because that's a good thing to know. Let's put that separately there. Okay. So now we're just gonna always set the size policy when we update the size. I think that'll work. Interesting that probably the only reason that it did work in the file manager is because we were setting an explicit fixed size policy. This layout system is a little bit limiting, I have to admit, but it's getting a little bit better over time. As long as it's like that, it doesn't really matter. But it would be nice if we could get back to what we were actually doing, which was the process manager. I have to rebuild everything because of C object change. I think these values here were essentially good, so we don't have to print them out anymore. All right. Can we please, finally, be able to resize this guy? There we go. Frickin' nice. Okay, now we can actually look at some of these stacks. I mean, they're all very similar, obviously, but oh shit, that's so weird. It doesn't grow when we, oop, didn't like that at all. Wait, why was it like that? Okay, so when we resize the splitter, we didn't resize the contents of the splitter? How does that make any sense? I can't help but feel that size policy, both of them are fixed. Does this make sense? Because that means that we're gonna set their size exactly. So that's fine, but then if we resize the splitter, then we have to also resize what's in here. Right. think maybe we can cheat. And we can say that the second resizee, his size policy is fill. And the first one is fixed because we only really need to change the first one anyway, and the second one will just use whatever space is remaining. It's kind of a silly solution, but I think it will work for our needs. Make it bigger, yep. Okay, so I think it's probably good enough for right now. It's a bit weird here that we don't really see anything that you can grab at, but that's a different problem for a different day. So let's remove that ludicrous spacing here. Just make sure that everything looks right. Then in Process Manager, yeah, that's more like it. I think this will probably look a lot cooler when we put the tabs on the bottom here. I'm not sure if we should, but I have a feeling that's going to look very cool. And yeah, we can't edit this thing now. Right. Very, very nifty. So I guess we got to kind of a cool place here. I think we should try to do a little batch review and see what we have. So I guess we have a whole bunch of stuff. Let's try to separate these things out into commits. So what did we do in C object? Just adding a comment. Well, let's do that one. Libcore, add a comment about child event happening for partially constructed children. Child. You can, since child added events originate from the C object constructor, they are not fully constructed when informing when their parent learns they were added. Comment. Added a little comment about this to the child declaration. Yeah, that's good to know. Then this was just me adding the process manager to start up by default, so we get rid of that. And this thing, I don't know what that was going to be, but I never made it, so let's just get rid of that. Okay, and then we have the GWidget changes. So GUI GWidget. Let's do it like that. Okay, so just adding a set size policy override for setting an individual orientation size policy. Git commit. And I don't like that I'm doing this in the same patch, but at the same time it's just removing an unused variable, so it doesn't really matter, or an unused function. So we'll say GWidget add an override, or this is ugly. Why am I doing that in the same commit? I don't like that. Should be disciplined about this type of stuff. GWidgets. Let's put it back. And oopsie. Add commit div cached. See what we're committing. Yeah, right. So now this is what the commit should look like. G widget and set size policy orientation policy. So to set the policy for a single orientation rather than both at the same time. Okay, now we can remove this. G widget. Remove unused is widget virtual. It's implemented as a Boolean bool member in C object, not a virtual. Just to verify that I'm right about that. Yeah, its widget actually just returns the mWidget Boolean. So there was no need for that virtual function. Okay, cool. So now the GSplitter stuff. So let's see what was up in there. Oh, adding some debug stuff. Get rid of that. So yeah, so this ended up being the whole fix. That one, I will allow this because it's the same file. And it's just removing a semicolon. Come on. No, oh, jeez. Wait, hold on. What am I doing? GSplitter. Okay. GSplitter. Explicitly set the size policy when resizing. If you don't have the fixed size policy first, resizing, the layout system will just ignore the preferred sizes that we're giving it. Yeah. Okay. And let's see, can we have something nice and separatable here? I think, yeah, this one we can do separately because it's kind of nice. So it's just adding the on process selected callback on the process table view. So I'll say process manager add callback process table view on process selected callback. It's really useful for doing something in response to the user selecting a different process. Okay, and finally, we should add these guys. Okay, so what did we do here? Well, it's a bunch of stuff. All right, so here we're just adding it to the makefile, process stacks widget, and here's the stacks widget. It's a simple G widget with a vertical layout, some margins to look nice, and then he has a text editor that's read-only, multi-line, and then we make a timer that every 1 second it will call refresh, and here's setPID that we call from the on process selected callback. When we also refresh immediately if you set a PID, otherwise it's every 1 second. Okay, and then here in refresh, we just try to open the proc PID stack file. If we can't, then we say this. And then we just slurp in the whole file and put that into the editor. Cool. Here's the declaration for that class. Very, very simple. GWidget just has PID, text editor, and timer. And then down here in main, we now put a splitter in the main widget, in the keeper widget, and then we add a second tab widget down here to that splitter along with the original one. And we put a stacks widget in the bottom, And then whenever the process table view a new process is selected, then we tell the stacks widget, hey, show that PID instead. So it's really, really straightforward. Process manager, add a process specific tab view to the bottom below the process table. To start out, there's a stacks view where we see the process selected. Process is currently doing. Yeah, proc PID stack. Cool. That's very, very cool. Okay, so I think, let's just see that one more time, but I think that we're going to be done here. Yeah, this is not perfect, but whatever. I'm gonna fix everything right now. And let's do that thing where something changes. So let's do like cat dev 0 dev home. And I just want to see it actually updating. That is very neat. Alright, well, if you made it this far, then I thank you for watching. I hope you saw something interesting today. And I hope you have a nice weekend. So, thanks for hanging out, and see you next time.